Students, let's discuss exercise 13.3 fifth sum. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. The ice cream is to be filled into cones of height 12 cm and diameter 6 cm having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. Actually, in this given question, a right circular container having full of ice cream. Okay, so that ice cream they filled into some such cones. The height 12 centimeter and diameter 6 centimeter. Okay, so here we need to find out how many such cones which can be filled with ice cream. But in this ice cream cone is looking like a cone surmounted by hemisphere. Okay, so here we know that the volume of right circular cylinder ice cream. Okay, the ice cream, the cylinder contains some ice cream. So the volume of that container ice cream is equal to the volume of some such cones ice cream. Okay, so then how to find out the number of cones? So let's take the volume of container is equal to number of times into the volume of ice creams in such cones. Okay, so we know that the volume of ice cream in cylinder equal to n into volume of one ice cream cone plus volume of hemispherical shape on the top. Okay, so already we discussed the ice cream is looking like hemisphere surmounted on cone. So the volume of ice cream in cylinder, we know the formula for volume of cylinder pi r square h equal to n into that is number of ice creams n into the volume of one ice cream 1 by 3 pi r square h2 r2 h2 and 2 by 3 pi r2 q. Okay, then substitute the values here. Thereafter you transpose except this and remaining values to the left hand side. So then you will be get 36 into 15 into 3 108 plus 54. After simplification you will be get n is equal to 10. So therefore 10 ice cream cones can be filled with the ice cream in the container. Students, let's discuss exercise 13.3 sixth sum. How many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimensions 5.5 centimeter into 10 centimeter into 3.5 centimeter. Okay, I'll read once again the same question. So how many silver coins? We need to find out the number of silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimensions. Okay, the cuboid dimension is given. Here we need to find out the number of coins required to melt to form cuboid. The dimension 5.5 10 into 3.5. Okay, the number of coins. So we know that the number of coins that is looking like which shape, that is cylinder. Okay, so the volume of number of coins equal to the volume of cuboids. In these questions here they given the diameter is centimeter but thickness is millimeter. Okay, so the thickness we need to change as centimeter. So if we change it into 10 centimeter we'll be get 0.2 centimeter. Okay, so the diameter is 1.75 meter, so the radius is 0.875 centimeter. So we know that the volume of n coins, number of coins, we don't know that how many coins, but such coins is equal to volume of this cuboids. Okay, so how many coins we need to add here to make equal to the volume of cuboids? So n into pi into r is 0.875 the whole square into 0.2 equal to length into breadth, that is volume of cube at 5.5 into 10 into 3.5. Okay, so except this n, remaining all the values transposed to right hand side. So at finally will be get n is equal to 400. So therefore the number of coins melted to form such a cuboid is 400. Students, let's discuss exercise 13.3 7 sum. A cylindrical bucket 32 centimeter high and with radius of base 18 centimeter is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. Okay, so already we know that a cylindrical bucket, it's filled with sand. At the same time, if emptied to the ground, it will make a conical heap. Okay, the conical heap, the height is given. The conical heap height is 24 centimeter. We need to find out radius and slant height. So from the given question, we must know that the volume of cylinder. Okay, so the volume of cylinder equal to this volume of cone. So volume of sand in the cylindrical bucket is equal to the volume of conical heap, sand conical heap. So we know the formula by R1 square into H1 equal to 1 by 3 by R2 square into H2, because the radius and height, that everything different. Okay, so for the differentiate purpose we took H1 R1 like this. Then substitute the values in the given question. If you substitute means easily we can find out the radius. Okay, so after substitute the values except R2, remaining all the values transposed to right hand side. So R2 equal to, and finally will be get R2 equal to 36 centimeter, because R2 square equal to 18 square into 4. Then R2 equal to square root of 18 square into 4. So 18 square is 8. Square root of 4 is 2. So R2 is 36 centimeter. Here we found the radius. Next we need to find out the slant height. So already you know that how to find out the slant height. This is looking like right angle triangle. That is one part. Okay. So slant height, hypotenuse, square of hypotenuse is equal to sum of squares of other two sides. Okay. So this side alone. So this side, the slant height equal to square root of sum of squares of other two sides, r square plus h square. So radius 36 and height 24. So at finally will be get 12 square root of 13 centimeter. Therefore, the radius and slant height of the conical heap are 36 centimeter and 12 square root of 13 centimeter. Students, let's discuss exercise 13.3 eighth sum. Water in canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. And how much area will it irrigate in 30 minutes? We need to find out that how much area. So that is dimensions, length and breadth in 30 minutes. If 8 centimeter of standing water is needed, so you know that we need to find out the area of irrigated water in 30 minutes. At the same time, the the height of the standing water is 8 centimeter. So here we know that the water in canal 6 meter wide. So wide is breadth and 1.5 meter deep. So the deep is height. Okay, and flowing with a speed of 10 kilometer per hour. That flowing water. Okay, the flowing is we consider as length. So the length is 10 kilometer per hour. But here everything given as meter. So 10,000 meter by 10,000 meter per hour. Okay, so 10 kilometer equal to 10,000 meter. Okay, actually this volume of water is equal to that volume of irrigated water. Okay, so here we need to find out the area and irrigated water. The height is given. Okay, so length into breadth, the area and height is 8 centimeter. Okay, at the same time here given that how much area will it irrigate in 30 minutes. Okay, the timing is given 30 minutes. But in this questions they given that flowing water is 10 kilometer per hour are only given, but we need to find out volume of water flowing in 30 minutes. Okay, so 31 hour, the 30 minutes means half an hour, 1 by 2. Okay, so the volume of water flowing in 30 minutes from canal, the required area is volume of irrigating water, the required area. So the volume of water flowing in 30 minutes from canal, so 30 minutes half an hour into, so we know that that is looking like a cuboid, length into breadth into height equal to area, the dimensions. Okay, so area to the height is given 8 centimeter. So centimeter we need to convert into meter. For that purpose only here I took 8 divided by 100. Okay, so the volume of irrigating, so that is also cuboid. So area is length into breadth, this is height. So 8 by 100. So thereafter substitute the values length, breadth, height, everything. Then the A alone keep it left hand side, remaining all the values transpose to right hand side. So A equal to 45,000 into 100 divided by 8. So area is 5,62,500 meters square. Therefore, the area irrigated in 30 minutes is 5,62,500 meter square.